Dinosaurs have always captured our imagination. From the moment their fossils were first discovered, people have been fascinated by these ancient giants and the mysteries of their world. We picture them running across ancient landscapes, hunting or escaping danger, their massive forms thundering over the earth. Movies, books, and documentaries often show them as fast and powerful creatures, capable of incredible feats of speed and strength. But how fast were they, really? Were they the swift predators we see on screen, or did they move at a much slower pace? This question has fascinated scientists and the public for decades, sparking debates and inspiring new research. Knowing how fast dinosaurs could move helps us understand their lives in greater detail, from how they hunted to how they avoided becoming prey themselves. It tells us about their hunting styles, their predators, and even their survival. Speed could mean the difference between life and death in the prehistoric world. If a T-Rex could sprint, it might chase down prey, dominating its environment as a top predator. If it was slow, its hunting tactics would be different, perhaps relying on ambush or scavenging rather than outright pursuit. Speed is key to painting a true picture of dinosaur life, shaping everything from migration patterns to social behavior. For many years, the idea of dinosaur speed came from their footprints preserved in ancient mud and rock. Fossilized tracks show us where they stepped and sometimes how they moved, offering rare glimpses into their daily activities. By measuring the distance between footprints, scientists estimated how quickly dinosaurs walked or ran, using math and physics to bring these creatures to life. These calculations formed the basis for many speed estimates, shaping our understanding of dinosaur behavior for generations. But what if these estimates are wrong? What if our assumptions about dinosaur speed have led us astray? What if dinosaurs moved slower than we thought, changing everything we know about their lives and interactions? A new study challenges old ideas and could change how we see these ancient giants, opening the door to a whole new understanding of dinosaur speed and behavior. For a long time, scientists relied on a simple formula. They measured the length between dinosaur footprints, called stride length. Next, they used the size of the dinosaur's leg bones, if available. With this information, they calculated how fast the dinosaur was moving. The basic idea was this: longer strides mean faster speeds. If a dinosaur left big gaps between each step, it must have been running. Shorter gaps suggest walking. This method worked well for comparing the movement of different dinosaurs. Researchers also compared dinosaur tracks to the footsteps of modern animals. They looked at birds, reptiles, and even mammals. By seeing how living creatures move, they hoped to unlock the secrets of extinct ones. These comparisons shaped much of our thinking. However, most of these methods did not consider the ground itself. Mud, sand, and rock all leave different kinds of footprints. What if the type of ground changed the size and shape of the track? This is where new research makes a difference. Not long ago, a team of curious scientists came up with a clever and creative idea that could change how we understand ancient animal movement. They wanted to investigate how different types of ground, especially soft, muddy surfaces, affect the footprints animals leave behind, and how this might impact our estimates of how fast those animals were moving. Instead of using massive, extinct dinosaurs for their experiment, they chose a living relative, the helmeted guinea fowl. This modern bird is distantly related to dinosaurs and shares some similarities in the way it moves. Helmeted guinea fowl are light, quick on their feet, and much easier to observe and study than their prehistoric cousins. The research team set up a special test track with different types of mud and let the guinea fowl walk and run across it, just as dinosaurs might have done millions of years ago. Using high-speed cameras and careful observation, they recorded the bird's movements and measured their exact speeds as they crossed the muddy surfaces. At the same time, they took precise measurements of the footprints left behind in the mud, noting their length, depth, and shape. This allowed the scientists to directly compare the real, observed speed of the birds with the speed that would be estimated just by looking at the footprints. The results were surprising and even a bit alarming for paleontologists. The footprints in the mud were often much longer and more stretched out than the actual stride of the bird, sometimes by a significant margin. This happened because the bird's feet would slide forward or sink deeper into the soft, wet ground, distorting the true length of their steps. As a result, when scientists used traditional formulas to estimate speed based on these stretched footprints, they ended up thinking the birds were running much faster than they actually were. This experiment revealed a major problem with how we interpret ancient footprints. If the footprints of modern birds in mud can mislead us, what does that mean for the footprints of ancient dinosaurs, which are often found in similar muddy rock layers? Many famous dinosaur tracks are preserved in mudstone, and these could be just as distorted as the guinea fowl tracks. This means that some of our old speed calculations for dinosaurs could be way off, and we may need to rethink how we interpret these ancient traces. The new study suggests we may have been overestimating dinosaur speeds for years. Mud changes the way footprints look. When a dinosaur stepped in soft ground, its foot might slip or press deeper. This made the stride seem longer. By using old formulas on these stretched footprints, scientists got higher speed numbers, but the real animals were moving much slower. The muddy ground distorted the evidence left behind. This means our past ideas of speedy dinosaurs need a second look. The researchers compared their guinea fowl data to dinosaur tracks found in similar muddy layers. The match was clear. Many dinosaur tracks showed the same stretching and distortion as the bird prints. It's likely that fossilized dinosaur footprints also exaggerated their speed. This realization has big consequences. It means that some of our most famous dinosaurs may have been slower than we thought. The way we imagine their lives and actions could change dramatically. Theropods are a fascinating group of bipedal dinosaurs, most of which were meat-eaters. They walked on two legs, much like modern birds, and their bodies were built for movement and hunting. Among the most famous theropods are Velociraptor and the mighty Tyrannosaurus rex, two names that have become legends in popular culture and science alike. For decades, these dinosaurs have been imagined as swift, agile predators, racing across prehistoric landscapes in pursuit of their prey. Blockbuster movies like Jurassic Park have cemented this image, showing them chasing down other dinosaurs at what seems like lightning speed, adding to their fearsome reputation. In the past, scientists often estimated how fast these dinosaurs could run by studying their fossilized footprints, especially those left in soft, muddy ground. Some early studies even suggested that a T-Rex could sprint at over 20 miles per hour, making it one of the fastest large predators of its time. Velociraptor, being smaller and lighter, was thought to be even quicker, darting through the undergrowth with incredible speed. But now, new research is challenging these long-held beliefs. Recent studies suggest we might need to lower those speed estimates quite a bit. If muddy tracks made the dinosaurs' strides appear longer than they actually were, then our calculations of their top speeds could be way off. This means that instead of being super fast runners, these dinosaurs may have moved at a much slower, more deliberate pace, especially in muddy or soft ground. So rather than relying solely on speed to catch their prey, they may have used other hunting strategies like ambush, patience, and careful stalking to survive and thrive. Teamwork could have played a much bigger role than we once thought, with packs working together to outsmart their prey. This new perspective really changes how we think about dinosaur behavior and their place in ancient ecosystems. T-Rex may not have needed to outrun its prey at all, but instead could have relied on its size, strength, and patience to ambush or overpower animals. Velociraptor too may have hunted in coordinated groups, using surprise and clever tactics rather than just speed. Our picture of these incredible animals becomes richer, more complex, and honestly, a lot more interesting as we learn more about their true lives. Fossilized dinosaur footprints are precious clues from the past. They're kind of like snapshots of ancient moments, you know? But mud can trick even the best scientists. When an animal steps in soft ground, its foot might slide or sink. The track becomes longer, wider, or deeper than it really should be. This makes it tough to know how fast the animal was actually moving. The same stride can look very different in mud compared to dry, firm soil. If we use the same formula for all tracks, we end up with wrong answers. The new guinea fowl study really highlights how important the ground is. By recreating muddy conditions, the researchers showed just how much tracks can change. The environment has to be considered every single time we estimate dinosaur speed. Ignoring these factors means getting the story wrong. We could imagine dinosaurs as faster or slower than they really were. Understanding the ground helps us get closer to the truth. This new research invites us to rethink so many things. If dinosaurs were slower, their hunting and escaping styles might have been pretty different. They may have relied more on stealth or surprise. Social behaviors, like moving in groups, might have mattered even more. The way predators and prey interacted could have been very different. Fast chases might have been rare. Instead, slow stalking or sudden ambushes could have played a bigger role in survival. Herbivores, too, may have used their size and groups for safety, not just speed. Changing our ideas about speed also affects how we see dinosaur environments. Maybe ancient forests and swamps were less about running and more about hiding, waiting, or working together. The whole ecosystem comes into sharper focus. Science is about asking new questions. This study shows that even things we thought we knew can change. It keeps us curious and open to surprises. This study is a good reminder for everyone. Science is not just about finding answers, it's also about questioning the methods we use. Sometimes the tools or ideas we rely on need to be updated or improved. For years, scientists trusted formulas based on stride length and footprint spacing. These worked well in some situations, but not in all. The guinea fowl experiment shows that even the best methods have limits. Science has to adapt as we learn more. It's important to look at evidence with fresh eyes. Every fossil, footprint, or bone can tell a new story. By testing old ideas, we get closer to the truth of ancient life. That's what makes science exciting and alive. When we question our assumptions, we improve our knowledge. Science grows stronger with every challenge and correction. Every new discovery adds to our understanding of dinosaurs. This study reminds us that science is always changing. The story of dinosaur speed isn't finished. It'll evolve as we find new fossils and develop better tools. We should actually be excited when old ideas are challenged. It means we're learning. Dinosaurs, once imagined as unstoppable runners, may have moved at a slower, more thoughtful pace. Their world was complex, and so were their lives. Our fascination with dinosaurs will continue. Each new piece of evidence gives us a better picture. The more we learn, the more amazing these ancient creatures become. Let's celebrate the questions as much as the answers. Science is a journey. The story of dinosaurs and our quest to understand them is far from over.